So we're going to pick up where we left off, still using the same functions that you have. And in this unit, you're going to be able to use that cheat sheet of different trig functions as long as you don't write on it and you don't lose that, right? So number one here, we got secant theta minus tangent theta all over 1 minus sine theta. We want to simplify this as much as we can and look for ways to do that. And we're just going to I'm going to ask for some ideas, things that we can do here. And what do you guys think on this one? What might an approach be, or something we can try? Yeah, Michael. Yeah. So one thing to do is, especially if you're stuck and not sure what to do, you can change everything in terms of sine and cosine. Can I Can I just move the sign up and make it cosecant? No. When can I do that? If there's only one term in the denominator. So how many terms in the denominator? Two. If I had cosine sine, would that be one term or two terms? One. It's when you have a minus sign or a plus sign that it makes it two terms. So I have a minus sign, so I got two terms, so we can't do that. But changing everything in terms of sine and cosine, not a bad idea. So secant is 1 over what? Cosine. Tangent is sine over cosine. And we still have the 1 minus sine theta. Okay? Michael? So are you saying focus on the top part? Make it one fraction? Okay, so we can subtract the fractions because there's cosine. So we got 1 minus sine theta over cosine theta all over 1 minus sine theta. And we already start to see this 1 minus sine theta forming twice. Okay. Can I take the cosine and move that to the top of this fraction? Yes. And I'm gonna do that because it's going to be helpful here. If I do that, what does cosine become when I move that to the top? Secant. And then I need to make sure the 1 minus sine theta that I'm putting it next to stays in parentheses, because that's a factor itself. And then that's all over 1 minus sine theta. You see what to do next? Now you can reduce. Yeah. Answer is secant theta. Okay. So we've simplified that down to secant theta. So the strategy we used, first of all, is to turn everything into terms of sine and cosine. We subtracted the two fractions. And then in one fraction, we moved the cosine to the numerator, made it secant, and then we reduced. So this next one is going to be like number one, but I'm going to give you a head start and have you try it first before I ask you what to do. So get a head start on this one. See if you can simplify number two. What are you trying first? I know you may not be done yet, but what are you trying first? Everything in terms of sine and cosine? Or a different method? Everything's fine? Okay. So cosine theta plus 1 over sine theta plus sine theta over cosine theta. That's the first thing? Okay. Now what? Chase? Okay. That would work, but that's going to be tough for some people to see. Okay. And I'm glad you see that. Let me give a little, let me give another option. Okay. So in the bottom, if it's split into two terms and you have a fraction, let's make one fraction out of that. But Chase, you do your way. That's good, and maybe we'll show that too. Okay. Cosine theta plus 1. Now, this is over 1, and when you add fractions, you need a common denominator, right? And so that first fraction, well, the sine over 1, I need to multiply top and bottom by cosine. And so when I do that, I'm going to end up with cosine theta sine theta plus sine theta all over cosine theta. Did I do too much there? Are we okay with that? So let me write something else here. So I'm multiplying top and bottom, sorry, by cosine here. Okay. So I got the sine, cosine plus sine, that's the top, and the bottom stays the same, right, when you add fractions. Okay. What do you see to do next? Okay. That's a good thing. And then another thing, when we have a fraction of a fraction, if we can get rid of that, that's another thing. Like if we could take that cosine, move it up, that might be helpful for some people to see. If I take this cosine, move it here, it's going to become secant, right? So you have cosine theta plus 1 over, I'll put it secant in front, so secant theta, and then all in parentheses we got the cosine theta sine theta plus sine theta. But eventually we want to do what Diego said is in this factor we can factor out a sine, and we'll be left with a cosine plus 1, and things will cancel out and open up for us. Yeah, so you can also move this secant to the top, it becomes cosine. You do, yeah? Just getting used to this. And once you get used to it and learn the rules of the game, it'll work out okay. But it can get a little complicated at first. So I got cosine theta plus 1 in the numerator. I have a secant, and I'm going to factor out a sine. So there's a multiplication sign in between those. And then what's left is a cosine theta plus 1. And in order to get rid of the cosine theta plus 1 up here, it has that the cosine and plus 1 have to be reduced together. And that we can reduce that together with the other cosine plus 1. So we are now at 1 over secant theta sine theta. And never, if you can get rid of a fraction, get rid of a fraction. So move these to the numerator. And what's the final answer? Cosine theta, well, I guess it's not a final answer. And maybe we should leave the sign there, huh? If we leave the sign there, you'll see something. Cotangent theta. Okay, so a few steps. I'm gonna few steps on that one. But again, if we look at what we did, we started by changing everything in terms of sine and cosine. If you have a fraction split up, we made one fraction. We moved things from the denominator to the numerator. We factored. We reduced. All that is part of that simplification. Okay. This next one's going to be a little more challenging, but doable. So write that down. Sine cubed theta plus cosine cubed theta over cosine squared theta times 1 plus tangent cubed theta. On this one, let's just talk about how you might want to start. So we could change things to sine and cosine, but there's something else that you want to do before that. Notice that this is a sum of two cubes. Good. And that needs to be factored. And then also this is a sum of two cubes. It needs to be factored, just like we factored sum of two cubes before. So you want to look for ways to factor things. And so let's start by factoring. So when we factor the numerator, sine cubed plus cosine cubed, that's going to be sine theta plus cosine theta. And what would the other factor be? Good job. Sine squared theta minus, so we square this, sine squared, and then we're going to multiply these two together, sine cosine. Plus the cosine squared theta. Okay. We have a cosine squared theta here. And then factor the 1 plus tangent. Yes. So we should have a minus sign here. Yeah, nothing looks like it's going to cancel out. It just looks more complicated at first. And it will get worse first, and then it'll get better. Okay, but there's a couple things here. Think Pythagorean identities. How can Pythagorean identities help us here? One plus tangent squared. We can add those together, and that becomes secant squared. That's one thing we want to do. And then there's another thing we can do. Sine squared plus cosine squared adds up to 1. So we can change those. All right. So we're gonna now have sine. Luis, I can't forget about you today. We gotta celebrate your birthday. All right, so you see in the numerator, I got rid of the sine squared and the cosine squared, I put a 1. Okay? And then in the denominator, I got rid of the 1 plus tangent squared, I replaced it with a secant squared. All right. Still doesn't look like we can do much here, right? But let's now change our tangent, our secant, and our tangent in terms of sine and cosine. So at this point, let's change everything in terms of sine and cosine and see if maybe something opens up for us. How are we doing? It may look intimidating, but are you following the steps? That's all I'm asking. Are you able to follow the steps? Any questions yet? So part of this is just knowing what to do next. Okay, what would we do? What would be a next good step? What's that? No. So when you have factors like this, where a fraction minus a fraction, make it one fraction. Same way here, make that one fraction. Okay, so both of these get a common denominator and add them together, or here subtract it together. So the numerator we're just leaving alone right now, working on the denominator. So on this first fraction, I'll do a little work before I put it in here. I'm going to change the 1 to cosine over cosine, so that I can add it with the sine over cosine. In the second factor, I'm going to multiply top and bottom by cosine. And so we're going to get cosine theta plus sine theta over cosine theta. And 1 minus sine theta cosine theta over cosine squared theta. So now we start to see a little bit of hope here, right? You got the 1 minus sine cosine, and that's matching. You got the sine plus cosine, this right here is matching that. What's the next thing you want to do? Distribute what? So if I multiply this cosine squared theta with this last factor, these will reduce. Which is nice. And then this factor I could reduce with this one. And so now we're left with sine theta plus cosine theta over, and then this cosine here, I'll move. So if I multiply this cosine squared with this fraction, so that you can think of this as cosine over 1, right? Okay. And then I have sine theta plus cosine theta times secant theta. See where that's coming from? The secant came from the cosine. I moved the cosine to the numerator of this fraction. And instead of writing cosine plus sine, I just flopped them, so that you see that these will reduce. And I get 1 over secant, which is, so it really simplified down to cosine, but there's a bit of digging to get there. Okay. Do you want me to go back to anything? You want to ask a question about any of those steps? Is that a little bit too much for you? Okay. Try 4. 4 will be easier than the last one. Hope not. So on 4, notice we have a cosecant of a negative theta. And so that angle does not match the angle for sine and cotangent and cosine. And when you simplify, you need to work with the same angle. And if you have a negative, you want to replace that negative with something else. So you have another set of identities, and they're called the opposite angle identities, right? It says something like sine of negative theta is equal to negative sine of theta, or the cosine of negative theta is just equal to the cosine of theta. And the tangent of negative theta is negative tangent of theta, right? And so although we're using cosecant, cosecant would go with which one? The sine, right? Because cosecant's 1 over sine. So cosecant's going to follow the same rule that sine does. And so you could just take that negative or replace it with a positive theta and put a negative in front, okay, by using yeah, no. Do you see it on your paper? On the formula sheet? And there's a reason behind that. I'm not going to go into that reason today, but we'll talk about that later. Okay, why it's one's positive, one's negative. But here, a good starting point is maybe to change everything to sine and cosine. And actually, we could just move this to the top. So all this is in parentheses, and when I move that up, it's going to become sine, right? And if I want to change it to theta, I need to put a negative in front of the sign. I'll take away the fraction. And then what would you do next? Probably, yeah, distribute this. And I end up with negative sine squared theta. And then a negative, the sine will cancel out with the other sign, so I get negative cosine squared theta. So it's cleaning up pretty good. Cosine times cosine. Where do we go from there? So I probably should factor out the negative. Maybe I should have left it out in the beginning, but it's okay. We can come back to this. So then I get sine squared plus cosine squared, which is negative 1. All right. One last one. Number 5. Square root of 10 secant theta plus 8 tangent theta squared minus 8 secant theta plus 10 tangent theta squared. I'll tell you the answer. The answer is 6. See if you can get to it.
Happy birthday to you.
Yeah. Okay. Very important, guys, that you know. So if I have this, if I have the square root of 64 plus 100, you cannot say that's 8 plus 10. You have to, because there's an implied parentheses which says you have to add before you take the square root. And so that applies to this too. Okay, how I got 160? Okay, so when you multiply out, when you do the 10 secant plus 8 tangent times 10 secant plus 8 tangent, do it on the side here. So you have to go 10 secant plus 8 tangent times another 10 secant plus 8 tangent. You see where it's coming out? You're going to go 10 times 8 is 80, and here's another 80, and you add that up, you get 160. So that's why I mean sometimes you can make a mistake and get the right answer, but you'd still lose credit. So you don't want to do that, okay? So here I'm gonna factor out the 36. Now left with secant squared theta minus tangent squared theta. What's secant squared theta minus tangent squared theta? 1. And that's 6. All right. I went pretty quick. I know we were shorter on time, but these are problems to go back, look at, try on your own. Okay. Your homework is the second page, all of it. Some are easier, some are challenging. Okay.